This video is on inverse functions. When we look at the definition, if we let f and g be two functions such that when you plug g into f, you get x for every x in the domain of g. You plug f into g, you get x for every x in the domain of f. So in other words, when you plug each function into the other, you have to reduce down to x in order for them to be inverses of each other. So the inverse of the function f is denoted by f inverse. We have the f with the superscript with -1, so it's read as f inverse. So that means we take f inverse and plug it into f. You take f and plug it into f inverse. They should reduce down to x. Once again, the domain of f is equal to the range of f inverse and vice versa. So just a mini example, if I had the function that was 1, 2, 3, 4, and 5, 6, as far as order pairs are concerned, f inverse would be 2, 1, 4, 3, and 6, 5. So you just flip the domain range. Okay, so show each function is the inverse of each other. So if I have f of x equal to 3x plus 2 and g of x equal to x minus 2 over 3, first thing I would do is take my g and plug it into f. So that would be 3x plus 2 minus 2 over 3. 2 and negative 2 would cancel, leaving with 3x over 3, and then that reduces down to x. Then I have to take f and plug it into g. Remember, they both have to reduce down to x. If one does it and the other one doesn't, then they are not inverses of each other. When you take g and plug it into f, it reduces down to x, and you take f and plug it into g, it reduces down to x. That solidifies that they are inverses of each other. So taking f and plugging it into g, that'll be 3 times x minus 2 over 3 plus 2. The 3's cancel, leaving you with x minus 2 plus 2, and then the 2's will cancel, leaving you with just x. So since they both reduce down to x, that shows that they are inverses of each other. Next, we will talk about one-to-one functions. A function that has each element in the domain corresponding to exactly one element in the range, vice versa, will be considered a one-to-one function. So it means no two different ordered pairs have the same second component. And the reason why this is important, because if the function is not one-to-one, then it does not have an inverse. So that's the first thing that we have to check for. Is our function one-to-one? If it is one-to-one, then great, we can go ahead and find the inverse. If it's not one-to-one, it does not have an inverse. So one of the tests that we can use, one of the easiest tests that we can use to determine whether a function is one-to-one or not, is the horizontal line test, which is very similar to the vertical line test for functions. Horizontal line test, if a line touches across the graph more than once, then it is not one-to-one. So here we have a few examples. The linear equation, of course, is one-to-one. You can draw, no matter where you draw your horizontal line, it won't touch it once. Your parabola is not one-to-one. Remember, your parabola is a function according to the vertical line test, but according to the horizontal line test, it's not a one-to-one function. It is a function, it's just not a one-to-one function. Here we have this wave, this curve that is not one-to-one, touches it 3 times with the horizontal line, and this cubic equation is one-to-one. No matter where you draw your horizontal line, it only touches it once. So the steps to finding the inverse of a function. First, you need to determine if the function is one-to-one. Once again, if it is not one-to-one, then there is not an inverse, so you don't have to continue on. But if the function is one-to-one, you continue on with steps 2 through 5. Once you establish whether it's one-to-one, you replace f of x with y. Then you interchange x and y, solve for y, and then for your final step, you replace your notation of y with f inverse of x. All right, so f of x is equal to 7x minus 5. We want to find the inverse of that. So first, we recognize that if we were to graph this is the linear equation. So that means it is one-to-one by the horizontal line test. Next step, we take f of x and plug in y. Third step, we interchange x and y. So in the fourth step, we solve for y, add 5 to both sides, then divide by 7. And y is equal to x plus 5 over 7. Finally, you will replace y with f inverse of x. So that would be the inverse function. Next, if f of x is equal to x plus 2 over x minus 3, we want to find the inverse of that. Looking at the graph, I drew a rough sketch here. We see that it is one-to-one. So we take f of x and plug in y for that. Remember, y and f of x are the same thing, just one is in function notation, the other one isn't. Step 3, we interchange x and y. So we have y equal to x plus 2 over x plus x minus 3. So if we interchange x and y, that will be x equal to y plus 2 over y minus 3. Now we want to solve for y. So we're going to multiply both sides by y minus 3 to get the y out of your denominator. That cancels, that quantity of y minus 3 cancels on the right. On the left, we have x times y minus 3. So distribute the x. That'll be xy minus 3x equal to y plus 2. So now what we have is we want to get all of our terms with y on one side, all of our terms without y to the other side, since we have more than one term that involves y. So we'll add 3x to both sides and subtract y from both sides. That will leave me with x, y minus y equal to 3x plus 2. Now that we have all of our terms with y on one side, we can factor out y from each term. That will be y times x minus 1 equal to 3x plus 2. Now divide both sides by x minus 1. They cancel on the left, leaving me with just y. And then on the right, 3x plus 2 over x minus 1. Final step, substitute f inverse of x with y for y. And f inverse of x is equal to 3x plus 2 over x minus 1. All right, let me know if you have any questions about inverse functions.